Well, greetings out there in YouTube land, and welcome to the long-awaited Part 8 of the never-ending saga of the Supro Tremo-Verb home build. Instead of keeping you in suspense till the end of the video to show you what it looks like, I just thought we'd have the grand reveal right now to reward your patience. Okay, we're going to take a quick tour of how it looks finished, and then we'll go through the steps that it took to get here, and then finally we'll hear how it sounds. First off, I think you'll of course see that decorative grill that's styled after 1947 National Deluxe amplifier. It's covered in an oxblood leather that reminds me a little of the red on that original Supro amp that we saw back in Part 1. As you can see, the all-important Danasonic nameplate is very happily perched on the front grille. You should also note that in the video description I've posted links to show you in detail how to install grill cloth, how to cover the amplifier cabinet, and how to make nameplates and plaques just like this. The covering for the main cabinet is a black hand tool leather pattern. My inspiration for this was the really snazzy Western style amps that Valco built for Gretsch back in the early 60s. You can see I've got the old-fashioned leather type handle up here with the stitching dyed to approximate the color of the front speaker grille. All of the hardware has been spray painted with gold lacquer and then clear coated to match the chassis finish. In the rear view we see that panel that covers the open rear of the chassis, and down below we see the reverb tank nestled in the bottom of the cabinet with the shielded cables connecting it to the chassis. Although I don't have the foot switch currently inside the cabinet, you can see there's plenty of room right here to set it inside along with the power cord. Now we can take a look up here at the gold painted chassis. You've seen it in several of the other video segments, but here it's all finished and installed. Here I'll tilt the cabin a little so you can get a view of the control panel without any shadows. Let's take one last pass around the amplifier so we can get a look at all of the construction details. And then let's spend a few minutes seeing how it got from the condition it was in at the end of Part 7 to the condition that it's in now. Okay, let's take a look at how the cabinet is covered. Now, I've already posted a video that shows step by step how this process is done in great detail, and I will put a link to that video in this video's description. For those who want to see the step-by-step process, please refer to that video, and for the rest of us, let's take a look just at this brief overview. Okay, in that video I used a 4-piece wrap. I did the two sides, and then I did a wrap around the top and the bottom that overlapped the edges of the sides. For this cabinet though, I decided on a 2-piece. Now what I did is I started right here in the center, and I put a center line on my upholstery material and a center line on the cabinet, and then I started and went left and right and then wrapped all the way around down here to the bottom. As you can see, the material comes in an extra like inch or inch and a half. Now what I'm going to do is wrap the bottom just like I did the one in the video, and it's going to come around here and will overlap part of this side. On this cabinet I put 2 heavy coats of the weld wood original contact cement on the wood, and then I sprayed the back of the covering material with 3M Super 77. And it really did stick nicely, I think. Okay, I've cut a piece of material here to wrap the bottom of the cabinet. Now I'm going to coat the wood with 2 coats of the weld wood, the back of the material here with the 3M, and I'll be back in just a second and we'll see how it looks. Okay, here is the bottom of the amp covered with the piece that wraps around that fixed rear door. Let me turn it around and we'll take a look inside. There, now you can see how this fixed panel here has the material wrapped around it. Let me turn the cabinet around and we'll take a look at the front. Okay, here I put in the speaker baffle to push down on the freshly glued and wrapped material to be sure that it sticks real tight. Then back here at the back, I still have to cover that panel that's going to enclose the rear of the chassis. Okay, here's the upper rear panel finished with the holes already burned through for the sheet metal screws to attach it to the chassis. Okay, Rusty, you ready? Here's the giant cookie. How much work are you going to do? You going to do a lot of work for me? Rusty? Oh, Lord. Okay, we have the grill cloth material cut out, and I'm ready to wrap it around the speaker baffle. This procedure is covered in detail in another one of my videos. I'll include a link in the video description. Well, here's the rear of the baffle with the grill cloth pulled tight and stapled. Then we look at the front, tight as a drum head, and the pattern coincides exactly with the edges of the baffle. Notice that I've cut away clearance for the speaker. You want nothing between your speaker and the baffle. Otherwise, if you have any high spots, you're liable to warp the basket. Now I've installed the Jensen speaker without its rear magnet cover. Used brand new number 10 machine screws and lock washers. We don't want this thing to disassemble itself during our Wembley Stadium concerts. Next, I solder the speaker input wire and input jack to the speaker lugs, and now it's ready to be installed in the cabinet. Here's a tip: before you install a speaker, be sure to spray the tips of the screws flat black, or else they're going to shine through the grill cloth like little LEDs. Here's the cabinet with the speaker baffle complete with grill cloth and speaker installed. You notice there's no shine through the grill cloth because everything's painted flat black. Next step is to build that decorative fretwork grill. Now, as far as that grill work over the speaker, I'm using a piece of tempered masonite here. It's about 1/4 inch thick, and I drew up a old-fashioned design and then cut it out with a saber saw. Now I'm going to cover it with a contrasting material. It's always a good idea to check the fit and make sure that you have a little room around the outside for where the material wraps around the edges. And here's how that fretwork grill looks like after it's covered with sort of an oxblood color material. Kind of tricky to cover one of these. Let's see how it looks in the cabinet. Okay, and here's the amp with that fretwork grill installed in front of the grill cloth. I also painted the screws and finishing washers gold to match the chassis. I installed a handle. It's one of those old-fashioned type, and it's got the maroon stitching. Jensen speakers installed, and the mod tank is now, I'm placing it in the bottom. I haven't put in the screws yet. And of course, we can't forget the rubber feet, courtesy of Home Depot, around $2.40 for a set of 4. Looking good. Okay, the reverb tank is installed in the cabinet. It is rubber mounted, so it should be free to move around about 1/16 of an inch back and forth and up and down. Also be sure that your output transducer is as far as possible from the power supply, which will be over here when the chassis is installed. This will greatly reduce the hum that's associated with a lot of reverbs. So here's a shot of the cabinet, ready now for the chassis to be installed. Okay, before I install the chassis, let's take a look inside now that the wiring is completed. This is the first preamp tube, which is V1. This is the tremolo tube, 12AX7. This is the 12AT7, which drives the reverb tank. And this is V4 here, which is the reverb recovery and the driver for the 6V6 or 6L6. Here's the input and output for the reverb tank. This is for the foot switches, tremolo and reverb, and this will be the speaker outlets 8 ohm and 4 ohm. Here we have the bias switch. These are the resistors that are appropriate for the 6L6. This is the resistor that's appropriate for the 6V6, and here is the cathode bypass capacitor. Here's the 5Y3 and the 6V6 or 6L6. We've already seen the power supply. There are no changes in it. One thing that should be noted in the power supply is the difference between the tan-bodied resistors, which are carbon film, and the gray or bluish-gray bodied resistors, which are metal oxide resistors. These are fairly stout. They tend to resist heat very well and hold their values very well. I've also labeled the tubes here on the bias switch so I know which tube is associated with which direction of the toggle. Now here's the top of the chassis underneath the control panel, where we have the input jacks and the 5 control pots. Notice that the wiring is considerably sparser than it is on the tube side, and I have a bunch of empty terminals here. Better to have too many than not enough, but if you're going to try to duplicate this build, you don't need to put as many terminal strips on the control side. One other thing that should be noted is the rather generous use of shielded cables. There's 1, 2, 3, 4, 5, 6, 7 that are out here crossing this no man's land between tube side and control side. It's best when you have a long run like this, carrying your weak signal back and forth between the components and your chassis, that you shield it from the electromagnetic radiation from both the transformers and the power supply. We're preparing a layout, a diagram of this circuit, and one of the main things that it will help you with is which side of the pot do you ground. The reason it's important is that depending on which side of the pot you ground, let's say the volume, for instance, the volume will either go up as you turn clockwise, or the volume will go up as you turn counterclockwise. Most of us like clockwise to increase the values. So you have to be careful. The pots are grounded, some of them on the left, some are on the right. Check the layout diagram and you'll see which side to ground the pots on. Well, that's about it for the circuit and the chassis. Be sure to check for the latest version of the schematic, which should be posted before the video goes out. So check all the values and all the changes. There have been quite a few that turned up while I was wiring this, and they're all reflected on that new revised schematic. Now here's an interesting chart. I'm not going to read it to you. You can pause the video if you'd like to read it, or go to the link that I've put in the video description. But what this covers is 3 different rectifiers that you can use in this chassis, and the B1, B2, and B3 node voltages that you'll get. Notice the significant increase with the GZ34. Then with a 6V6 tube and a 756 ohm cathode bias resistor, these would be the readings for plate dissipation. As you can see, this particular arrangement with a 5Y3 and this cathode bias resistor yields an optimum plate dissipation. This is the setting that I used. And here's a second chart. In this case, instead of a 5Y3 tube, it's a 5881, which is equivalent to a 6L6GB. With the 654 ohm cathode bias resistor, I end up with 45 milliamps of plate current, which is about all that I can expect from the transformer that I've used in this build, and a plate dissipation of 15.1 watts, which is rather low for a 6L6, but we'll see in a few minutes how it sounds. Using these other rectifiers gets the plate current level up to rather uncomfortable levels. So if you wanted to bias your 6L6 up around 20 or 21 watts, you would have to use a GZ34 and a power transformer that had a higher high voltage current capability. Wonder where Jack is. I need him to help me with my new video. Oh no, he's up here snorting catnip again. I guess we'll have to take you back to rehab. Well, I finally got the chassis mounted in the cabinet. Got the reverb tank connected. The speaker is plugged in up here at the 8 ohm outlet. We're flipped to the 6v6 bias. Now let's install the back panel and see how it looks. Okay, well, the reverse strip tease is finally completed. Here's the rear panel held in with the traditional gold hardware. And as you can see, there's plenty of room to stash the power cord, and the foot switch fits right in here. Okay, so that's it. And here's the final cost analysis of the Supro build. I'm not going to take the time to read every detail to you. I just hate it when people show me a slide or a chart and then read it to me. But as you can see, the total is $657.50. Now bear in mind that I did every single bit of this myself. Nothing was done outside. Therefore, my labor was, I would estimate, around 100 hours. I shudder to think what it would have cost to go to a Finnish carpenter and have them build the finger-jointed cabinet, and then go to a metalworking shop and have them machine and finish the chassis, and then go to a electrical engineer and have them do all the point-to-point wiring. I think you can see that you probably end up with a total here that was about 5 times this amount. But since I did all the work myself, I guess it's up to me to place a value on my hourly wage. And to be honest, with the amount of work that it took to build this amplifier fresh in my mind, I would be hard put to turn loose of it for less than $2,000, which sounds absolutely astronomical for a home-built amp. But what would that be, $13 or $14 an hour, which isn't much more than minimum wage nowadays. But that's the way it goes when you home-build amplifiers. They are definitely a labor of love. Now it's time to see how it sounds. Okay, it's time to see how it sounds. Now we've got a lot of ground to cover, a lot of effects, different settings, and 2 different tubes. So I'm only going to strum a few chords in each of those settings so that you can make some sort of comparison. And now the 5881. Well, that about does it for this grueling but rewarding 32-day project. I have a few thoughts before we come to a close on this video series. First off, what you heard in the sound check was exactly how the amp sounded upon completion. The amp tone circuit was unchanged. It was absolutely dead quiet. There was no hum of any sort. The volume, I think, is just huge. The switches work perfectly. And in person, the 6L6 is a little bit warmer than the 6V6, which surprised me. It weighs in at 32 pounds, which is 2 pounds less than a Princeton Reverb. Physically, it's about as nice as I can make it. As far as sound goes, I think it's a little deficient in bass response. And I think that the tremolo is a little too strong. I can't believe I would say that, but it actually cuts out some notes when it's set up around 10 on intensity. I will address these issues and I'll report my findings. Meanwhile, Rusty, Jack, and I want to thank you for your patience and support. We hope the video series is helpful and that you all stay healthy and join us again for future videos and comments. Bye for now.